Okay, now I'm going to move way beyond the lactating cow today and the pre-calving animal, and I'm going to go to time of conception. A little bit of what Michelle was saying as well. What happens when I conceive that embryo that will be a cow, that I'm dealing actually with a cow today, but she was conceived 2.5 years ago or 3 years ago? We tend to forget that 75% of the lactation, or of the pregnancy, coincides with gestation. So in other words, 75% of the gestation or the life of the fetus is miserable, okay? The fetus is competing with nutrients with the mammary gland for 70% of its life. How should we feed the fetus? NRC says no requirements, are negligible until 190 days of gestation. So forget about the fetus until the cow becomes dry. What happens to humans when our wives or women get pregnant? The next day, they're on vitamin B12, folic acid, a whole bunch of supplements. What happens to a high-producing lactating cow when she becomes pregnant? Nothing. And I think that's going to change in the future. In what direction? We're exploring it, and we're doing studies on it, but we don't know what direction we're going to go. This is an example of what happens with sheep, which has been the model used for this type of studies for a long time. These are lambs that were born to use, that were control-fed, according to requirements, or restricted by 30% of their requirements. At birth, there are no apparent difference between the lambs born to control use or restricted use. However, at time of slaughter, and I think these animals were slaughtered at 14 months, lambs born to restricted use, and we could do the same thinking in our heads, well, those are calves born to lactating animals, okay? This is a competition for nutrients. They had a greater fat deposition, they were fatter, and they had also a greater kidney pelvic fat deposition when their dams were restricted. So in other words, we're programming. What nature is doing is, well, the fetus is sensing that the world is miserable, so she needs to come up with ways metabolically to become really efficient of storing energy, whatever energy is available. When they are born and they are placed on a plentiful environment with lots of nutrients, now they're still programmed to be very efficient on storing fat, and they become fat. And I don't want my cows to be like that. And we have some evidence, and I'll show you some this afternoon as well, that this actually is happening with our cows. There is a study is no longer in press, that was published actually 2 years ago, sorry about this. 0 would be the amount of milk production that the heifers born to heifers, non-lactating animals, produced. And then this is the milk production in the first lactation of animals that were born to a first lactation animal, second lactation in red, or third lactation in blue. As parity number increases of the dam, milk production in the first lactation of the animal is lower. Why is lower? Well, these animals have a greater tendency to become fat. They have a greater tendency for ketosis. We have some data on that as well. And they produce less milk. Can we correct this? I think we can, and we need to nourish our pregnant cows properly. That's also an interesting study that illustrates that when the dam is pregnant, and she's carrying that baby that will milk 2 or 3 years later, if she has somatic cell counts high, in other words, if she has mastitis, if she has 1 case of mastitis that in pregnancy, no big deal, 2, no big deal, 3, no big deal, 4 or 5, anti-Mullerian hormone significantly decreases in the offspring of those cows that had mastitis while pregnant. What is anti-Mullerian hormone? Well, has been linked to the capacity of the ovaries to produce follicles. The greater the AMH you have, the greater ovulatory capacity you have. And there is some studies actually that say that then they follow these animals, and animals born to cows that had repeated mastitis cases than in pregnancy, they had a delayed age at first calving, probably because they had lower AMH in their blood.